Yes. Yeah, it's great to be on here and talking again. It's been a few months, but for those who don't know, I'm Dave Kimura. You can find me on Twitter or really just about anywhere with the handle at Cobalt. And if you want to check out what Drift and Ruby is, it is www.driftandruby.com, where I produce and release screencasts mainly on Ruby on Rails stuff. And so, talking about machine learning, it's kind of one of those interesting things because I think that there is a lot of misunderstanding about what machine learning, artificial intelligence is. And I'm going to get a lot of this incorrect as well, but I'm okay with that. But prior to the whole wave of ChatGPT from OpenAI, there was something called Web3. And Web3 was hit by the storm. And I think it became really popular in some circles, but I think it was misdefined. So I'm going to redefine it first. So Web3 is all about AI. Forget that crypto thing. It's all about AI because that's where the world is going and that's what people have, decided. Now I'm joking, but not joking. So a lot of my experience with machine learning has been with LLM or large language models. I have not done my own individual smaller model training. I've done really just using large models. Think of it like ChatGPT. And so that's really what we're going to focus on in this talk today. And as far as my background with machine learning, I think it can most accurately be explained with a GIF. And here it is. I am not an expert at all in machine learning. So I actually got some of my slides mixed up. So let me go back and fix that. Yeah. So I do not know a lot of the technical underlying algorithms or anything like that. But I know enough to be dangerous. And I think a lot of people are kind of in that same boat. It really is the wild west of computing nowadays. So this talk is also not going to be using OpenAI because while I think OpenAI is awesome, I think it's also extremely dangerous if we are building our business around OpenAI. And I say this because look at the recent struggle that some people are having with a company called Reddit. Reddit had an open API for a long time that people can freely use, and they are now charging for it. So, for some very popular apps that were using their API, are now going to have to pay a lot of money just to have their application continue to function. And so, during this whole adventure of machine learning, OpenAI opened the door for me to AI, but I've kind of went in my own direction with my exploration. So this talk is going to be more about hosting your own machine learning model. So basically, this is a picture of my server rack at home. And within there, I have some GPUs within there. These are not enterprise grade graphics cards by any means, but instead they are just more consumer friendly, more consumer priced GPUs. But the important bit is they have enough VRAM to host the models that I'm wanting to host. And a funny thing is that I'm actually using these in production right now because I am any video that I upload to Drift and Ruby now goes through some machine learning algorithms. So I do a transcribing. So any of the words that I speak within that video are now automatically transcribed, and I store that within the database. It also then auto generates the closed captions. And I found that with the model that I'm using, I'm getting over 98% accuracy. So it's actually really not bad, especially for something that's just being hosted in my basement. So what I'm doing with these is adding the closed captions to the videos. So as people watch it, they could actually, if they have maybe a hearing impairment or something, then they have an accessible way to still be able to understand what is being said. but then also I'm using it for the search engine. While it is a lower priority in the search, whenever you search for something that maybe was said within a video, then you would be able to see which videos had those kind of words mentioned in it. So it is a lower priority. The title, the summary, the code content, or the show notes would obviously have a higher priority. But at least this way, if you watched a video 5 years ago and you wanted to figure out, I remember Dave said something like this within his video, but I can't remember what it was exactly, then this is going to give you a better chance to be able to find it. So that's how I'm using AI in my real business. But when we talk about AI, and especially around using this kind of stuff, I think it's important to understand some of the terminology. And again, I'm basically the Ralph Wiggins of AI stuff. So this is going to be high level stuff, and some of it could be a bit inaccurate, but we'll just deal with that. So let's go through some of the terminology. First, you have a model. And a model is basically that core thing of your AI. It can be a file that is basically defining the relationship between the label Y and the features X. So uh, it we're going to dive into models a lot more, but that's essentially what a model is. So you basically have a large language model or some other kind of model that you have then done training on. That training you can then consume what you basically have taught that model. And so let's jump into the next definition of training. And training is the input data used to calculate the parameters of the model. So basically, if you are doing some kind of like a language translation from English to Japanese or something, then you would have something like hello equals konnichiwa or something similar. So that's essentially what your training is. You're feeding it parameters that you are then allowing that model to learn. And then when you actually go to consume the model, then that's called the inference. And that's basically you now have a model that's up and running and it's in production, and now you need to use it. So essentially, that's what your inference is. So those are just some very high level definitions that it's important to know. So then we get into how do you train a model and what is really kind of the different techniques around that. And I'm just going to hit on some of the few high level ones. You have supervised learning, and that's when the model is trained on data with known answers. So, like the language example, where we have a English version and then the equivalent Japanese version, that would be considered a supervised learning. Then you can go into the unsupervised learning, and that is where you really don't have that kind of information to say, if this, then that, or this equals that, this would be the expected result, but instead feeding it something like a website. If you just want to feed it Wikipedia and then have it try to find its own relationships and that kind of stuff, then you're more in the unsupervised learning. And that can be a lot more complicated, a lot more mixed results, and takes a lot more data. Then you get into reinforcement learning, and that's when it's really kind of the non supervised learning, but then you're giving it user feedback. So if you are telling it to uh, go from this to that and it gives you some kind of response from the inference, you can say, no, that's bad, or yes, that's good. Do that a few billion times, and now you have a more finely tuned model. So those are just some of the high level overviews. I don't really want to focus on that stuff too much because I want to focus more on the different types of models that we can create. And when you are getting started with machine learning, I think the best and really the only way I would recommend is to find a problem that you currently actually have. If you go out and just say, I want to learn machine learning, I want to learn AI, because that's the latest thing, then you're going to have problems because the different types of models out there that you're able to create stuff around is insane. There's many, many different kinds of models, and these models you could really make an entire career out of just one of these. Doing for example, like a Tesla car does image classification, it does video classification, it does all of this stuff that you can really just focus on one of those things. And that's just one model out of all the different other kind of options. So find a real world problem that you have that you think that AI could be a solution for and go down that rabbit hole. I think that you'll yield better results and you'll be more focused and learn a lot more. As you finish that project, you can move on to other things. So, just to talk about some of the hardware that I'm going to be using in this talk and that I have at my disposal for AI learning, the most important thing right now, and this could change in the future as Apple progresses with its neural engine, but it really is NVIDIA. NVIDIA is kind of like the king right now of machine learning because of their CUDA cores. And the reason why CUDA really matters so much is that CPUs are incredibly bad at performing calculations, even though that's really what they're meant for. The thing is about CUDA cores is that they are very good at math, doing matrix and vector maths. And you don't just have a 4 core or 8 threads to work with. A graphics card will have thousands of CUDA cores. And the more CUDA cores you have, the more you're able to calculate at the same time. And that's why using graphics cards and hosting your model within that GPU memory is so important. So the model that I'm going to be working with and the GPU that I'm using in this episode or within this is an RTX 4080. It's not a cheap graphics card. You can do this with much smaller ones, but this particular model and the size that I'm working with, you can see is just under 14 gigabytes of VRAM, which is nearing the max of what this $1,000 graphics card is able to do. And the computer that I had this in, it's a small form factor computer. And I just kind of like drew some lines of where everything is on this computer. I have the graphics card at the bottom, I have a CPU and some RAM and a fairly large power supply to be able to power that power hungry GPU. And this is basically the specs of this. It's not a cheap computer by any stretch of the imagination. But if you are getting into machine learning, you don't have to go out and spend almost $3,000 to do this. You can start if you have an Apple computer, you can try to get as far as you can with that and stuff. So don't think that you do have to go out and spend a lot. And if you look at these specs, if you don't know much about computer specifications and stuff, this is a baller computer. It is like extremely high end. And it's also, yeah,
Based based on your specs, that is more powerful than most of the like Apple workstations. My machine is older. I built it for $1,500, but that was the height of the chip shortage just during COVID. And I built it for 1,500, and it is more powerful than a $10,000 iMac Pro workstation.
yep.
Yours is more powerful than a $50,000 iMac Pro workstation.
Oh, absolutely. Yeah, the Intel iMac or the Mac Pro actually have one sitting in my basement not being used because the 13-inch M1 was able to surpass it. So it wasn't a $50,000 computer, but still. So if you did want to, like, say, money's not a problem, I want to get into machine learning, I want to get my feet wet, go out and spend 3 grand and you can, get really far. So in this talk, I am going to be using a website called Hugging Face. Hugging Face is a tremendous website. Think of Hugging Face kind of like the GitHub for machine learning. You are able to use Git protocol to push up new projects. You can push up your models. You can run different kind of actions and stuff around them. Hugging Face really is the GitHub for machine learning. And specifically, we are going to, in this talk tonight, we're going to look at a GPT example. So this is not Chat GPT, but this is rather a 7 billion instruction set called Falcon. And it is a large language model. And we are basically going to ask it questions. and we are going to get a response. So, assuming that you have a nice computer with a NVIDIA graphics card and you already have Python installed, that's where we are going to kind of pick up from here. So, I'm first going to install transformers, which is the Hugging Face way to basically interact with your model. And again, sorry about this, but this is all Python code, even though this is a Ruby meetup. But we are going to be looking at some Ruby code, so don't worry. But I'm going to try to feel free to mute me during all this Python jibber jabber if you like. So, anyways, we have pip, which is basically our package manager for Python. We're installing a library called transformers, and that's how you interact with the Hugging Face models. There's a lot of different things that you can do with it, including like downloading the model. You can even do some fine tuning on your model where you basically are taking an existing model and you have some specific data sets, which are basically that supervised learning that you're wanting to feed into that model to fine tune it, to then have a new model that's been fine tuned. You can then push that fine tuned model up to Hugging Face and then deploy it or pull it down somewhere else. And then we're also going to be using PyTorch. And PyTorch is basically one of two standard de facto libraries for machine learning. You basically have PyTorch, and then you also have, oh, I'm hitting a brain fart here, but it doesn't matter because we're going to be looking at PyTorch in this. So here is the entire model or the entire bit of code for machine learning. The first line, we are importing in a library, a couple of different modules from the transformers. I don't know why I'm then importing in the whole transformers. We don't really need to. But then we are importing in Torch. So this is basically your requires where we are just bringing in the external libraries or gems that we're going to be using. Then we are declaring our model. The model is that Falcon instruction set that we mentioned earlier. And then the tokenizer. The tokenizer is basically where you have your model and then you want to run your inference on there. So basically, it is then going to take whatever kind of input that you're giving it, and then it's going to run it through your model to get your outputs. So you can't just give a machine learning model English text, it doesn't understand that. But what it does understand is numbers. And again, that's where the CUDA cores come in. So the tokenizer will convert it over into an array of numbers or into a matrix. And then it's then going to be able to run it through the model, which is just a very large matrix of data. And then our pipeline is basically just another function that's going to run the inference. So the pipeline in this case, we are again still using that Falcon model, and then we are using a float 16, which is, perhaps isn't the best float value to use. It can affect the accuracy, but that's what I'm using here. And then the sequences is essentially where I am giving it my parameter. So we have this sequence for the pipeline. I'm giving it the prompt, tell me a joke. I want the model to give me a maximum of 200 tokens back or about 200 words or so. And then at the bottom here, that's going to, the sequences is going to give me a hash back. And with that hash, I just want to print the result. So let's run this and see what happens. Well, we get the full text. So this is the entire thing that is returned back. Tell me a joke. So it repeated what I told it. And then it is then giving me the rest of the bit. So where this is very different from ChatGPT is that this is kind of a text generation. So essentially, this is not a question and answer model because I'm not asking it a question. I said, tell me a joke, and then it is trying to predict what I'm going to say next. So we can ask it questions and it can sort of give us the answer, but it's more like if you were writing down on a piece of paper, you know, tell me a joke, and then you are still just writing down. That's essentially what the large language model here is trying to do. So it's cute, but it's not very useful as it is because you execute it once, it loads it into the GPU memory, and then it's done. So I want to use this in a real world application, but my real world application is a Rails application, not a Python app. So the best way that I found to do this is microservices. Yeah, I hate microservices, but long live microservices because they are solving my problem here. So we need to take our original bit of code and we need to change it. We need to just tweak it a little bit, and here's what it's going to look like. So that sequences I moved into its own function or a method called generate text. That generate text takes in one parameter, a prompt, and you can see now we have a prompt within that pipeline instead of the static or hard coded text, tell me a joke. I'm then just returning the generated text, but I'm replacing the prompt with an empty string. And the reason why I'm doing that is because I don't care to see back what I fed into the model. So this makes it kind of more like the question and answer kind of model where I'm giving it some text and then it's responding. But this also is not very useful because now we can just run this, but then it doesn't really do anything because it's not going to stay running. It's just going to execute this and then see, like, okay, well, it's done. So, what we need to do is then need to take this and put a web wrapper around it. So, again, I'm not a Python person, but here's my implementation of a very simple microservice app where I'm going to use Flask. And Flask is kind of think of it like the web brick of the Python world. You probably want to use a different service like G Unicorn or something like that if you are going to be doing this in production. I actually do run mine on G Unicorn instead of Flask, just because it's apparently more battle tested for production use. I named that file, this file, where we are consuming our model main.py. So from that main.py, I'm importing in the function generate text. I then initialize the Flask app, and then I create a route /generate with the method post. It's then going to handle the request, taking in the prompt from the form or from that form post, and then we are calling the generate text with the prompt, and then we are returning the text. The last bit is just telling it to run the application, binding it so that we can communicate it from outside of just that local host machine on port 8000. To start this, if we call this file web.py, you just run web.py. So I think it's only fair to show you a demo of this. So let me close this out and let me find my mouse. So Joe asks CUDA cores. Yeah, it's the CUDA. It's specific to NVIDIA graphics cards. And you can get for under $400 a graphics card. It's the RTX 3060 for which has 12 gigabytes of VRAM, which is more than enough to tinker around with your own models. So if you're talking about large language models, that's where you get into a lot of trouble because the amount of VRAM that they use up is insane. So those are usually going to be a lot harder to host. I just happen to find a few that are small enough that you can host on consumer graphics cards. But if you're doing machine learning, creating your own models, doing your own training, you can get away with just about any kind of video card or even CPU based. As far as Dennis's question, how does this compare using resources in the cloud? If you were to get a GPU uh, on AWS or Google's cloud computing, they do have some really powerful GPUs, but you're also going to be paying a heck of a lot for it. In realistic, what you're gonna find with the GPUs there, that you are getting a portion of is that they are significantly slower than the bang for the buck that you can get with consumer GPUs. But the enterprise GPUs do have error correcting, which is very important, and they are also geared and battle tested for this kind of production use. I have a folder here, and this folder has gpt.py. Let's look at it. It is literally that first example where it is going to tell me a joke. So let's run that. Actually, before I run that, I do have to come in here because I actually have a chat bot running and it's eating up all my GPU right now on this server. So I need to quit that before I continue. So I can just run the Python, eh, Python, and then GPT, and it's then going to load that entire model into memory. It's then going to run that one function or command, and then it's going to give me the output. Ignoring all the warnings it's throwing, we get the result. Tell me a joke. Man walks into the bar stool falls over. He looks around, asks the bartender, why did the bar fall over? The bartender says, I don't know. Must have been okay. I don't think that's a very funny joke, but yes. So, that's pretty dangerous to do on a live coding thing that we don't know what the expected result's going to be. But I'm going to pull up here my other window running. So this little spike, the orange spike, was the memory it was loading up, and then it was a pretty short spike for the actual computation. So that's our machine model. And so let's keep kind of moving on because we can do so much fun with this. So let's look at the second example where we actually made it into a microservice. So we have that web.py. I'm going to run the Python and then the web.py. It again is going to load that into memory. And we will see in the little graph here that it loaded the whole thing up into memory. Now it's running and it's ready to accept web requests. And this is the IP address that it's hosted on. So I'm going to use a tool called Rapid API, which is formerly called PAW. And then I can make a request to that. You'll see that it's going through doing some things on the GPU. It also had a quick little spike, and we could just kind of keep refreshing this, and you can see that running this on a GPU is actually very fast. So some of these jokes are horrible, but I love it. Um, but now we're kind of getting into familiar territory because now we are actually making a web request, which from our Rails experience, we're kind of familiar with. And I want to use this in my Rails application. The worst thing that I can do in my Rails application is to make this request directly from a controller because we are making an external request. If this service ever goes down, then you are not going to get the expected result. So we want to put all of this into a background job. And so with the background jobs in Rails, I am going to use Sidekick for this example. But I mean, really, you can use any background worker as long as it's active job, really. And this is what it looks like. It's not long, it's very simple. And perhaps one of the most important things about this is that I'm queuing it as a different queue because I know that the GPU has limited resources, even though now it's wrapped in a web application. If I were to make two requests to it concurrently, then it'll actually process both requests because the model's already loaded in memory. It's able to then do both of those concurrently. But if the requests typically take 10 seconds, now those two requests are going to take 20 seconds because it can't just pull resources out of thin air. So it's having to divide and conquer, handling both of those requests at the same time. So I do have a couple little of guard clauses or catches if it returns an error. So if there is a read timeout or connection refused, could be if the Python application is trying to boot up or something, then it's going to wait a few seconds and then just keep trying again. We then have the guts of our background job, and that is the perform. And in this case, I have a model called Ask GPT that just has a question attribute and an answer attribute. I then also have a status just so we know where it is in that process of, is it still pending? Is it processing? Is it completed? Just so we can get some kind of idea. So then I'm getting the prompt or the question that was asked. I'm making an HTTP post, which this is just a HTTP class that I created that just wraps around net HTTP. It's nothing fancy. I can show it to you if y'all like to see it. But we are setting that response to the variable called answer. So we are making a request to that Python service from that URL. You'll see it's that local IP address / generate. It's a HTTP post passing in the parameter prompt. If we did get some kind of response back, then we're going to set the answer to what we got the response of, change our stats to completed, save it. Otherwise, we're going to say that it failed. So let's see a demo of that. And our demo is actually going to be ai.railsapp.dev. But before we do that, I have to enable that service again. So bear with me here. I can kind of show you. I have a bunch of computers that I'm hosting, but this is on the Ubuntu. But before I do that, I have to stop this service because I need to free up the GPU memory. So you'll see the GPU went from like 13 gigabytes all the way down to near zero. But if I go into my stacks and if I enable this chat stack, it is on this computer. We will see it shortly spin up pretty high in the GPU memory again. And if you're unfamiliar with what Portainer is, this is just a web interface for Docker. And it basically allows me to manage my Docker instance remotely. So it's really cool. I really like it and suggest it. But I am actually running this model on, yeah. So I'm actually running this large language model on Docker on that computer. So this is kind of what that service looks like, where I just tell it what my image name is, the command that I want to run. I'm doing some port forwarding. The important bits is Docker needs to have access to the PCI card or that GPU. And so I can pass or give access to that GPU and then also tell it that it has that capability. So that's up and running now. We can see it spike up there. So it's ready to go. So this is the silly little website that I created. It's just my playground for different kind of AI stuff. So I have a lot of different models on here that I'm actually using in production. So like the transcriptions is where you can upload a video and then you are getting some kind of text back. It's transcribing it for you. So I'm using that for all my Drift and Ruby videos as well as the closed caption where it then creates it in a format that I can then attach to the videos. So for the accessible needed, they are able to then get some kind of closed captions. We can also do text to image, which is really fun. But if you don't enter in a prompt, then I have a default prompt that gets generated. It's something like a children's book, tiger, or monkeys or something. But you can see it going from a pending to processing state. It'll go through all the calculations on my server. And then once it's completed, then it'll hit the completed stage, hides that progress bar, and then it'll download and then show the image. You can kind of do the same thing with a text to speech where people have created a bunch of different little text to speeches here where we can do a hello world. We create that record, and this again is a Rails application. It goes from a pending state to processing. It'll do all the calculations on the server. And then once it's done, it will go into the completed state. And then the screen will automatically refresh. And then we have access to that generated voice or the speech synthesis. So I don't know if you can hear it from my microphone, but it said hello world in a very computery kind of voice. But then to kind of demonstrate what we had done earlier with the GPT model, we can ask it a question. So we can do ask a question. It does tell me a joke. Why do scientists trust atoms? Because they make up everything. Wait, that should be why don't scientists trust atoms? Because they make up everything. Yeah, see, you cannot trust generated text from GPTs. You got to read what they're writing and put in, your own logic to see whether or not it's accurate. But with this idea of asking a question, getting it a response, just this question and answer kind of thing isn't very useful. So I've taken that idea and I expanded upon it, where as I give it more information, it'll look back and then it'll then carry on a conversation. So I did not put that in there, but thank you, whoever did. That's funny. I'm scared to read what that response is, so I'm not going to. So we'll ask a question. How can I write a Ruby net HTTP request to an API endpoint? It'll then give me some kind of response. We'll wait for the response. We get the response, and that actually doesn't look too bad. At a first glance, that looks like it could work. I don't know what that usenet is, and I don't know if send is exactly correct, but this is a good starting point. But so I've asked correct. Yes, Falcon. Yes. So I've asked it this question, but like, oh, nuts. I did not give it enough information. While it did answer me directly, I want to expand on this. Now, make this net HTTP request a post request. And let's see what it responds back with. So it's now taken into context what I asked before, not what it gave back, but just what I asked before and what I've asked now. And now it's given me the response. So now it's making a net HTTP post, passing in some parameters. And we're done. That's all I have for y'all. Let me go back to the chat.
I believe Joshua has his hand raised.
Yes.
I don't, but
Oh.
thank you. That was, yeah, what I don't understand about AI, and I think maybe still, it's just how it's able to keep the context of the conversation and keep building off it. This just blows my mind.
Yeah, you can do language chain, I think, in order to do that. I'm not doing that. I'm doing a very dirty implementation. Like, I will show it to you if you really want to see it, and it's ugly. Let's have a look at it while I'm still sharing my screen. So this is the actual thing that is doing the language chaining or whatever. So I basically have an array, and here, let me make this a little bit bigger just so I can hide some of the nasty code here. I wrote this at like 1 a.m. So, but anywho, I created an array. The conversation, each conversation has many exchanges. The exchange is where you have the question and answer. So I assorted descending. I'm just grabbing the last three. And this is a super awesome Ruby method. If you don't know it, it's called excluding, which basically I have an active record collection and I want to exclude the most recent conversation item because in here we are performing with the ID exchange. I'm setting that exchange with that ID. So I'm basically grabbing the conversational items that preceded it, excluding that actual exchange. And then just loop through it backwards. Within that array, I'm injecting in the question to plain text. And here's my little hack. I take the question mark that you may or may not have had and I replace it with a period. Because if I have a question mark in the original text, then it gets really angry and it's going to try to answer that question again. But if I phrase it as a sentence instead of a question, then when we actually get down to my question bit, or you can see here, I'm injecting in the latest question that was asked that this background job is trying to process, then it's going to have the question mark at the end if you typed a grammatically correct sentence, and it'll then answer more contextually accurate to what you asked it.
Wow. That's crazy. Yeah, the period question mark thing. Because I've been playing with ChatGPT. No, I was just gonna say that's kind of a brilliant hack because I've tried to do this kind of thing just with just in the ChatGPT interface, and yeah, and that's really what I was gonna say.
Yeah, and as you're kind of working with these large language models, you might have something like a question like, "What is the tallest mountain?" But if you feed this into a large language model, you may not get the expected results. It might go on some kind of crazy tangent. But there's a hack that you can do. You can do question, what is the tallest mountain? And then you can do answer and feed that into your model because a lot of these models are going to try to do a text completion. And if you are leaving it as a text completion like this, you'll see I have GitHub Copilot on here, and GitHub Copilot is trying to suggest Mount Everest. So that's kind of the another hack around with working with some of these large language models that you can kind of get more to the expected result. Okay, so hey, we can open a queue of questions. Bailey, you have a question?
Are you going to implement a vector database? Because what you implemented is a pseudo in-memory vector database.
Yeah, so the actual model itself, I think, would be considered a vector database because it's just a bunch of numbers that are basically being stored on that GPU memory. But for the Rails application side, that wouldn't make much sense simply because I'm displaying this conversation. So this conversation that we are then saving back to the database, I want to show back to the user in plain text. So I think it makes a lot of sense to keep it in a natural language format. But then when it gets sent over to the Hugging Face model, or in this case, the Falcon that I'm hosting, then it still goes through that tokenizer, which then turns it into the vector array that can then be infer go through the inference on the large language model. And Nelson, you had your hand raised?
Yeah. What learning resources did you use to get yourself familiar with this? Was it all Hugging Face, or what did you use?
Let me go to that Hugging Face. Let's see, Hugging Face, and let's look up Falcon. Hey, oh wow, they have a 40 billion. So, you can actually find, I copied and pasted that original code, changing the original text to tell me a joke. So what I found is a lot of these models that are hosted on Hugging Face are actually really good about their documentation on how to use them. So I would first, if I was starting out, I would first go to the list of models to find what am I really kind of looking for. if I don't know what the exact kind of model it is that I want to use, I would actually ask ChatGPT to give some recommendations of different models to use because it's been trained on a lot of this data and it, you know, as of September 2021, its records reflect that it knows about this. So really GPT and Hugging Face, the docs on the different models is how I learned and how I got this far so far.
And I had a second question.
Yeah.
So my understanding of language models is that there are options sometimes of language models that are larger and some that are smaller, and the larger ones require more memory and processing power, and the smaller ones just work quicker and they use up fewer resources. So did you select large language models to use with your hardware, or are you using more efficient ones?
So there's been plenty of models that I've tried that I've just ran out of GPU memory. And there are some ways around that where you can change like your float bits down to 8, but the accuracy is going to be less. So you're not going to get as accurate results. And at that point, you might as well use a smaller model, a model that has been trained on less instructions than to try to fit a larger one. But essentially, yeah, I picked the models I'm able to use within my own grasp. And one really cool thing that you may not know is that OpenAI has an account on here. Oh, come on. I don't know the name. But OpenAI actually has their Whisper model on Hugging Face that you can actually download and then you can do your own transcriptions. So it'll take whatever kind of video that you feed it or audio, and it'll actually be able to transcribe it and give you English back. And they actually have some tiny models, which are, again, not going to be exactly accurate. I'm actually running the large V2 on my GPUs to do the Drift and Ruby ones, and I've not fine tuned it yet. So it's all just based off of what it already knows and what it provides. I can bet you, Frank, that if you went with a medium or large model, it would be viable to self-host and do it today. I mean, Ren, you have a question?
Yeah, so kind of an odd question and more like a little bit abstract, and if you don't want to answer it, that's totally fine. I'm just curious if you feel like this is going to continue to stay like such a big field to work through because there's so many models and everything, or do you feel like this is going to start getting privatized and people are going to get apps built and then they're going to go, oh, cool, now you have to pay for it?
Yeah, and it's such a hard question because there's so many let me just take a stab at this. So my problem with OpenAI is that they're not going anywhere and they are massive. To train GPT-4 with the way they did costs millions of dollars just to create that model. And that's not even hosting. That's just to create the model because the amount of data and the GPU, the server time required to crunch all that data is insane. Even if what you're getting back is very tiny, just the sheer amount of data is crazy. So machine learning is not accessible to the general consumer. But then you have Hugging Face and these wonderful people who have created and spent hundreds of thousands or millions of dollars or a crap ton of time creating some large language models that we are able to use, fine tune, and get our own um, fine tuned data from. So I don't think it's going anywhere, but as awesome as what OpenAI can do, I would first see if you one have resources where you can provide your own hardware. And notice that I'm hosting all of this from my basement. Like it's literally on my server rack at home. Drift and Ruby is up in the cloud. And so I have a on one of these, I have a small container that just listens for web requests and then it takes it in, runs it in a background job and uploads the response. So I'm not hosting Drift and Ruby out of my basement. That's up in the cloud because it needs to be. But this stuff that's happening in the background, I can run offsite on my own hardware. It doesn't have to be cloud proper. So I really do kind of run a hybrid setup here, and it's been very nice on my wallet.
Hey, just a quick question. Earlier you had a screenshot with the two GPUs, and then I saw the splash screen for the computer that was like, I think it was like 2,800 bucks. What would you suggest for just a hobbyist getting into it, just to make some things work? And then what would be like the minimum implementation for like an enterprise level local LLM, that if that makes sense?
Yeah. So for the consumerist, definitely a NVIDIA graphics card. You don't even have to have the latest and greatest, but one of the main specs that you would focus on is the amount of VRAM that it has. So the RTX 3060 GPU, you can get them in the 12 gigabyte variant, which is enough to work on some of the large language models. But again, if you're not doing large language models, if you're doing your own customized models and your own details, which um, if you have Xcode on your computer, there is something called Core ML that's included with Xcode. Oh, why is it not showing up? Is it Core ML? Create ML. Create ML. And this will actually use your local computer. Let's just go into I don't know where I want to do this. New document. This is built into Xcode where you can use your Apple computer to create your own machine learning models. And it's going to create it in a core ML format. But then there's some documentation out there on how you can convert this over into a Hugging Face model or one that you can use with PyTorch. So you may already have the hardware you need to get started if you are wanting to do your own kind of machine learning stuff. As far as production, again, you have the route of going with cloud hosted services and using GPUs on VMs or within Docker containers, or you can buy your own hardware. The important bit for the hardware is going to be graphics cards that have enough VRAM to run the inference on the model that you're wanting, but then also the error correcting. So the former Quadro cards, which NVIDIA has the RTX 6000, which is the current line is the ADA. See, I love going to the shop button and then let's go to professional graphics cards. And you can see like even the last generation, you get a massive amount of GPU memory, but you're also paying a pretty penny for it. If you go with the current generation, which is significantly faster, you still get only 48. I say only, that's a massive amount. You get 48 gigabytes of VRAM with error correcting, and that's almost 7,000. So it's not cheap. Like, definitely, I don't have these cards. I would love them to have that much VRAM, but it's just not, I will never see an ROI on that.
And you would just put that on like Ubuntu latest or
Yep.
any Linux distro?
Yeah, really, the distro that I'm running right now, fetch. It's running Ubuntu 22.04, and I have Docker on here, and that's where the actual chat model is being ran from. Yeah, there are special flags that you have to do with the resources, like the deploy resources and that kind of stuff. I can share what that looked like for that stack. This is it, Frank. So in the environment, I tell it CUDA, if I had multiple graphics cards, I could specify all, or I could specify like one for the second graphics card or zero for the first one. And then I pass in the capabilities, compute and utility. And then under deploy, resources, reservations, devices, capabilities, gotta include that GPU, right? There are other questions, Bailey?
I wanted to know, have you tried TensorFlow Lite?
Uh, TensorFlow, that was the other one. No, I haven't.
Some of my hobby projects, I am using TensorFlow Lite binaries on mobile devices. Even like my cheap Samsung can run TensorFlow Lite machine learning models. They're not as capable as a full TensorFlow model, but they have most of the functionality I need for my stuff. And you can have, let's say, if you use a React Native or Flutter, you can have a TensorFlow Lite machine learning model running locally for certain functionality that you would machine learning for. And if it work on a phone, it should be able to work on a server. And while you were talking about having the machine learning model on your home network and then piping it out to the cloud, of course, obviously to save money. I went, well, could you try TensorFlow Lite on a server? And I did a quick Google search, and there is a demonstration on Medium on running a Flask app with a TensorFlow Lite machine learning model on a minimum tier of the node, $5 a month. So if you could convert that model to a TensorFlow Lite model somehow, and TensorFlow Lite does have a conversion API, I'm not super familiar with it, you theoretically could run it on totally in the cloud.
But yeah, in fairness,
there are performance costs, but if it's good enough, keyword if.
And I'm gonna say for a large language model, it will not be. From my experience, and just that, tell me a joke. I ran this on the CPU, which is a 7950. I mean, that's a 32 thread CPU. It took 40 seconds to generate a response. This was under 1 second when using the GPU. I mean, we're talking like 80 times slower on super high end capability CPUs. But to that point, if we are talking about mobile, I would start with that Create ML. Download Xcode, give this a shot, because chances are you're going to need an iOS application. And I think this would be a good way to get your feet wet in the mobile space. That's a 1060 probably. Okay. I nailed that one. I nailed that one. Yeah. So yes and no. That's just the number of parameters it was trained on, which means its size is also going to be larger as those billions increase. So, like the Whisper model that I mentioned, they have a tiny one which was trained on very few parameters. But yeah, and it's like 85% accurate, and that would be more than enough. You could probably run that medium model on there. The large, I think, takes around 8 gigabytes of VRAM or so. So, I mean, again, I am not a machine learning expert. I've just played around enough with this to talk about it for 40 minutes. Yeah, Nelson.
Yeah, are you gonna make this code available, like open source it, or because I'm curious to play around, but I think it would speed up my playing around to just use code that you've already written.
Yeah, absolutely. And you know where I'm probably going to go with this. There's an episode for that. So this episode is basically using the Flash transformers. It's for the stable diffusion model, which is the image generation. And I basically go through how you create a background job and all of that in a lot more detail. So beep, beep, beep. Thank you.
Thank you for a great presentation. That was really awesome.
Thanks.